Okay. So still we're talking about the computing for the scalable system. Um, last time we discussed two architectures. Uh, so now you know what shared memory architecture is and what kind of program that you are using for shared memory architectures. You are using Bthreads and OpenMP, and I hope that now we are using this efficiently. And also we discussed GPU architectures and CUDA programming. Unfortunately, we don't have GPU computer to practice, but hopefully in the future we will have. And I will inform you that if you want to come and practice, definitely we can create an account for you and to practice, because I'm sure that you are going to use query programs in many computing problems. And today we'll talk about the last architectures, which is distributed neural architectures. And this time we'll use different programming library. This programming library is a message passing interface, or MPI. And so it's about it. So this architecture is completely different from the previous one, because shared memory architectures, we have different processors, but that processors share a common memory. But for distributed memory architectures, we have different processors, and each processor is completely independent. By processors, we mean that it has registers, it has cache, memory, is completely independent computers, but they're connected together by what we call interconnect. And interconnects, there are different kind of interconnect. The best interconnect now, InfiniBand, which one is the most fast interconnect, and the modern network, they are depending on this InfiniBand interconnect to create what we call it computer clusters. So this is the so most modern computer clusters, they are depending on this architecture. They have different CPUs, and each CPUs will have dependent memory and registers, cache, everything, and even a storage system, but they connected together. So in architecture like that, if you want to use this in parallel computing, because this is the idea behind using a parallel computing, because we need to use a multiple computer to use them simultaneously to solve a problem fast and in very scalable way. So to use this, we have to use a different specific kind of programming library. So we are using a message passing interface, or MPI, and so this is so this unit will be about this. So what MPI, or message passing interface? So this generally about the distributed memory system, we are using MPI, or message passing interface, and this kind of programs that is can be classified as single instruction, multiple data. It's the same like before. We have a single program, and that program can be executed in all processors. All processors, but of course they have different data, but they work simultaneously. And so this is the idea behind this. It's the same like OpenMP, but the difference there is they have shared memory, and we use threads. Threads also, they can operate simultaneously or in parallel, but the only difference is that they have shared memory. But here they have the CPUs are completely independent, and So they have to use this message passing interface to communicate with one another, to communicate with two computers or CPUs. They can communicate using this programming library to do parallel job. Okay, so this is the idea behind this. So now we will come to some term process. What do you mean by process? Before we defined this process when we were talking about the in Unit 1 introductions. We defined process, and also we defined threads. A process, a program that can be executed in a single processor. Okay. But inside that process, we may find different threads. So this is the difference between that. So once you have a program that can be executed in independent processes, that means this, we call it process generally. Or sometimes if you say processors, that means you refer to the hardware. But when we say process, that we mean the process itself, the result of the code or the code itself that is executed in the processor. Okay, so this term is important because once we say process, that we mean code that will be executed in independent processor. So the MPI or message passing interface is about a parallel system, because now from the this course to teach parallel system, because if you want to learn C or C++, of course you can learn it in other class. But here's the focus specifically about how to use, you learn different architectures, but how to use those programs on those architectures and distributed memory architectures. This is one of them. And by the way, most of the cluster computers, and by computer cluster, sorry, we mean high performance computing systems, is found in most of the institutions, and we have many. I promised you in the beginning of this semester that to show you our HPCs, which we found in IRC, and I hope if you visit me at any time there, I will show you how those supercomputers are there and how they look like. Okay, so those the MPI is used in HPC or high performance computer because those they consist from different nodes and separate independent processors connected with interconnect, and then it will be very efficient to use this kind of library to use to solve scientific computing problem in parallel. Okay, so this MPI implemented in C or C++. When we say C, it's like C++ because we are using them in different coding system. C++, of course, evolved from C, and when we use in code, we are using them together, so that is okay. But this MPI is implemented in C or C++, and Fortran, which is formal translation, and those are the first powerful language used for scientific computing since a long time. So they are very well established. For intermediate language like Python, now there is library they're using MPI for, and other libraries or modules. They are trying also to implement MPI, because MPI is implementation that any language they can implement the standards of MPIs and to benefit from that standard to develop workframes that they can use it for parallel computing. But if you are using it, always you have to think that you are using MPI in C or C++ and Fortran. But also you can use it with MPI4, but of course in scientific computing, we do not recommend to use Python because Python is interpreted language it is very good to use, scientific computing in compiled language. Okay. So now we'll talk about little history about the MPI. By the way, MPI started as a standards group of scientists gathered together in hotel in Austria, this in 1990, and they put that standard, so that the first standard for MPI to develop a standard for our library or framework that can be implemented by a computer language for parallel system. So like different processes, they can benefit, they can communicate with one another. So this is the idea in began in 1990. And after that, different versions, and MPI 1 specification, it was 1994. It added some library and become more usable in high performance computer. After that, in 1996 also, MPI 2 also, they add some extensions and library. And in 2012, we have MPI 3. So this become like more developed. So they add new extensions and become more usable and portable and can be implemented by many platforms. So that we began the version 1 in 1994, and it still is keep developing and to add more standard. So what is the MPI programming models? So it is distributed programming model. That means it works in distributed memory architecture that completely independent architectures. And just let me try to use this sketch to show. So here we have like different computers, like we call them like CPU. And when we say actually CPUs, that each CPU will have all part of CPU. That means central processing unit. They have arithmetic units and also registers and cache. All of them will be in the CPU. And each of these CPU also will connect to the memory. So why we call this memory or RAM? So each of one of these is completely independent computers or CPUs, but in a network, these computers are connected with an interconnect. Okay, so this is the architecture that. So when you use some MPI programs, you run it, the same program, the same software, you are running it in all, you run it in all processors, but how to communicate together, because they are completely independent, and of course they have to communicate with one another to do parallel job. And always when we talk about the parallel job or computing, always think about that computing is happening simultaneously. That means at the same time. It's not sequential, okay? Because sequential means there will be some kind of time will be in serial way, but in parallel, that means all the computing will happen at the same time, okay? So this is the difference behind that. So to do that, the program in when you use the MPI, so the program will be executing each of those processors. Okay, so the same program, so why we call it single program or single instruction, but multiple data. But each of these processors may have different kind of data. Okay, so how to communicate like this CPU to communicate with this? Of course, they have interconnect, but this communication provided by MPI message passing interface library. So this is the library that we will focus on and we discuss. We'll try to discuss it in details, and we do also some kind of practical coding. And I want you also to use our Hyperion high performance computing, and all of you already have accounts there. I want you to use that accounts and use it. Okay. So this it is in distributed programming manner, hardware platform, distributed, shared, and hybrid as well. And also this is something good because, and especially these the implementations, the modern implementation in MPI 2 and MPI 3, now they can use them in hybrid. Okay, but parallel system is explicit. By explicit, that means you have to code it. Okay, it's not like something that the compiler will understand if you want to develop that parallel or not. But no, you need to code it and that what we mean by explicit. It's not implicit. It's explicit parallel system. That means you have to do some kind of coding to do that. And really, there is something very important. I want to understand it. The numbers of tasks dedicated to run parallel program is static. By static, actually, that means you have to determine how many processes that you want to use, how many processes. Okay, and of course, this is depend on the capacity of your cluster computing, like how many processors is allowed to use, and you can use that accordingly. And in most cases, if you are using like HPC's high performance computing, and you may use some kind of scheduler, because the computing resources will be managed by a management program like Slurm, for example, and then you can allocate a specific number of processors and a specific size of memories and so on. But if you want to run, if you want to run a MPI program, then you have to determine the number of processors that you want to use during the runtime. And here we will show you some examples how that. But I want you to remember this: in parallel program is static. So that means the number of processors you must determine it during the runtime. Okay, so this is something that we'll come and discuss it. So what is good about the MPI, or massive pulse interface? Because it has been evolved since 1990. So now it's become portable. And by portable, it means that we don't need to change the same code. You can use it in any platform. It doesn't matter, whether like Intel or, so all platform, and there are different kind of platform like Unix and different, you can use it. So why it is, so why we call it portable? Because you don't need to change the code. Always you are using the same codes. And also the standards. It's standard, why? Because they are different implementation, but all of them, they follow the same standards. The framework might be different, but when you run it, you are using the same standard. Okay, so why we call it standard also? Because you may use different MPI, and we will come and mention some MPI version, but all of them, they are using the same standard specification specified by the MPI consortium. Functionality also, there are many functions that they will use, and you will learn some of these functions here in this course. And availability is available. Some of them, they are commercial with some platform, and some of them are open source. you can download them and install them freely. Okay, so this why. There are some implementation. By implementation means that already we have the standards, and so you can implement if you have your own a computer system. If you develop your own computer system, then you can implement yours. That means you will use your own code, but you will implement that standard because that scientists, they agreed on that standard to be something that something to be generalized. So I don't need to learn the language. Like if I move from, for example, from platform to a different platform, I don't need to learn this language. I need to use the same coding, to use the same compiler, and to execute the program also in the same way. So why isn't? So one of the most popular implementations include Open MPI, and this, if you are using high performance computing, you will find Open MPI. Okay, so it's very scalable, it's very powerful, and also you will find MPI SH, and this one also is like implementation that aims for high performance computing as well. Also, you can use, there's the Intel MPI, and this for Intel processor or Intel computer. They have their own implementation for MPI, and also there is MV ABISH MPI, and this for InfiniBand interconnect, because when you this is special kind of network, so the computer, they are connected with interbus, but that with bus or interconnect, but that interconnect is very fast. It is very fast, and now most of the modern network, they depend on this kind of technology because it makes the transfer of data is very fast. So why they are using this, and also they are using this special implementations of MPI because they need transfer itself to be very fast. Okay, so when you use like any network or cluster computer, you need to know the specification of that and what kind of interconnect they use, what kind of MPI implementation also they use, because also you will benefit from that one. And also they have IPM, Spectrum MPI, they develop their own for their system architectures, and Cray MPI, and here we have Cray, old Cray, and unfortunately actually it doesn't work, but also Cray develop their own implementations as well. So this diagram show, already we explained it to you before here. So when you develop your own program, it is in C or C++, but it uses MPI library. When you compile it, you will create the executable file, and once you run executable files, you need to determine the number of processors that you're going to use. So, and I want you to focus this, and I want you to pay attention on this. When you run, once you compile it, and when you come to run it, you have to specify the number of processors that you're going to use in the computing. Okay, this is, and now here, because here we have 4 different processors, that means we have we specify 5, and when we come and show you the first program, I will show you how you provide that processor. So that program, it will run in each of these CPUs, and I'm going to repeat again because this is single instructions but multiple data. Okay, so the different data in each of these processors, but we are using the same code. So this is the architectures and programming behind that. So now we're going to show you this. Always, when we come to talk about the parallel system, always we have to remind you the sequential system as well. Like sequential is just the code will be implemented sequential, right? So, for example, like here we have hello world. It will be executed by a single processor, and by a single processor. So this will be executed by single processors, and so can you see the screen? Yes, I want to make sure that you see. Can you see this terminal? You can see the terminal, right?
Yes, sir.
All right. Okay. So we're gonna make directory class just to practice on it. And so if you create the first program, of course, already we know that we have to do like if you include library. So std h, this for input output device, std, and then of course if we'll use the main so this time I'm going to print if okay. So this this is just like a normal code, and C++ that already you know. And when we run this, if there is no any error include, then we can run this, compile this C++ return, sorry. And return, and also here we can add a space, new line as well. So okay, and if you want to run it, it will be run. So it will. This is just like a single processor because this is sequential. So what is the difference between sequential and parallel in MPI? Okay, so before a multi-threading that we know, when you use OpenMP, we'll use some kind of directive. But here we are using some kind of function, and first thing we need to add. So now I'm going to convert this into parallel. That means we will execute this print hello world. I want them to execute executed by any number of processors that I decide during the runtime. Okay. So here we need to include MPI MPI.h, right? MPI.h. If it is not, tell me, because really the screen is very far from me and it is very small screen. So once you added this, so you need to add this directive. And library are included in this directive as we explained before, because this is the header directive that includes the library. So now if to convert this, now I'm going to give you the first two functions that you use. First, because we have to enter some parameters. We have to enter some parameters. And one of these parameters, we have to determine the number of processors during the runtime. And when we say actually during, because once we compile a source program of a compiled language like this, that means we will translate this code into machine code. So the only thing to interact with a program during the runtime, that means we will use the command line, okay? And if you want to command line, then we have, as we discussed before, and I don't want you to forget this. Here we have to enter. We have to enter some parameters here. Okay, so like RC, so this is like the number of parameters that we will enter for the command line, and then we will char, and this must be like double pointers. Okay, and we can give it name like argv. Okay, and you know why? Because we need to use command line to enter some parameters, and then parameters will be passed to the program. Without using this, we will not be able. argc, it will tell us about the number of parameters that enters. And argv, it will include the parameters that we enter, okay, which will include the number of processors. So why we call this statics, and we have to provide the number of processors. So there are two. To convert this serial program, you have to add two. Later on, of course, we will learn more about other functions as well now, and how those processors communicate with each other. But now we want to show you that just how to, this very simple program, how to convert it to parallel programs that we run it in multiple processors. Okay, so this is the idea behind that. So in this case, we're going to use two functions, or we're going to use MPI, okay, init, right? And this is going to take address, it's going to take memory address, argc, and the second one also a memory address, and it will be argv, and then semicolon. So this is the first function. This function means that we need to initialize, so it will tell the compiler this, we need to run this in parallel or in all identified processors. If we define like 5 processors, that means any code after this will be executed in parallel, that means in all that processor, okay? So I want you to take this, because this is the understanding of MPI begin from right here, okay? So you have to use MPI init, and then provide the argument or parameters, and that parameters already we receive them from the main function, and later on I will show you why we are using this. Okay, we are using it to pass the number of processors, and the second function is we need to finalize. Okay, again, we use MPI underscore finalize. And here, there is no any parameters. But don't forget the semicolon. So now, if finalize, if everything is, there is no any error and we compile it, so this will be executed in the number of processors that we will determine during the runtime. And now I'm going to show you how, because we need to compile this first, because this is the source code. We need to compile it. After compilation, we need to run or execute it, okay? Just we will make sure that everything is fine. So we use two functions. The first function will initialize the parallel job, and the last one is finalize it. That means there is no, if you type any code after MPI finalize, it will be run sequentially, okay? So without wasting time, so I want you also to pay attention to this here. So this time, because we are using MPI library, we are using different compiler. And the compiler here we are using MPI, okay, and C++, this one of them. Again, if you want to create like executable file, this optional, you can dash O, that means we create executable file and we will give it a name. But also, if you delete it, it will give you default name, which is a dot out, like before. Okay, so let's go and check if there is no error. Then it will be okay. There is no any error. So now we need to run it. Remember that we have only single sentence, hello world, and we need to, this time we don't want to run it sequentially, but we run it in parallel in multiple processors. So to run it, we have to use again MPI, but this time we add run. Don't forget this. And dash Q, quiet, because sometimes maybe, you know, it will, if you take these parameters, then the operating system might complain. We'll give you some help and so on. So you want everything to be very clear, okay? And then MPI, that means the number of processors. A number of processors, now we're going to put like 4, okay? This is why I mean that you have to determine the number of processors during the runtime, because already we have the program already compiled, okay? We have already compiled it, and this is the name of the program. We compile it, okay? It is compiled language. So now if we want to run it, we have to determine the number of processors, and this is what we mean that we have to determine that you have to use that parameters in your program in a specific way to take this from the command line. So when we run this, see how many, so instead of a single, now we run them in 4 processors because we determine 4 processors, and that depends on how many processors you have. If you have 10 processors, also you can run them in 10 processors and so on. So if this, when you are using computing, of course that depends on how many processors that you have to determine in advance how many processors you need for your job, okay, when you are using MPI. 20 processors, any processors, because now we have many processors, also you can run that. So the idea behind this, it is, now we learn 2 functions, and this function, it make it, parallel system. So anything you put here, it will be in parallel system. Now I'm going to show you something. Suppose that if you have like 5 we have processors, and we need each processor to do a specific thing. For example, like for loop or any function to be executed, you can create your own function here. So let's do like int function sum vector, okay, and so if integer x, for example, and or we learned that if you want to like do a function, we have also to determine the number, the size, for example, okay. So we need integer also sum. We're going to initialize it to 0, and then we need to add for integers I equal to 0, I less than size I incremented by 1. Okay. So now if we need to add sum plus equal, so we have x. Okay, that means here we're going to add this, and because the type is integer, so we're going to return sum. I believe you know this, you understand this. A function is just like a function. And now we need this function if it is correct. I don't know if maybe we get error and we'll come back and fix it. And there should be an error because here must be a data type integer as well. Let's review this integer, that's fine. Initialize to 0, and then integer I is equal to 0, I less than size already determined. And then we increment it, and okay, that will be fine. Okay, so now we have the function. Now we need, instead of this, we need this function to be executed in here. Okay, that means each processor will execute this function. But before that, also we need to determine integer x. Let's do this because we have to declare integer 12, 15, 10, 10. Okay, 1, 2, 3, 4. Okay, so we can also make like the size, integer size, it is 5. I think you know all this because we discussed this. Like here we initialize array, vectors, one dimension array with 5 elements, and here just we declare it implicitly because we didn't determine the number of size here, but the size also will be 5. So we can run this here in parallel region and to see how. So instead of that, we can make some like change here, print sum. So each one we need each one to bring sum. And by the way, because we can use this later on, maybe we'll discuss why we create this small d, and then we can use comma and add some vector integer x, size 5. Okay, so this it will so let's just run this. If there is any error, it will tell us, but hopefully there is no error. So that means if it works very fine, it will print each one, it will sum this number and will print it. Okay, if there is error, it will tell us if there is error. Let's just go and yeah, if you have a question, feel free to ask. Do you have a question, Chris?
So Simon was trying to draw attention to the code.
What you say?
Yes, Simon was trying to draw attention to the return word in the code.
Okay. So there is something. Okay, so just return. Yeah, you have to return.
When we are calling the function something in the MPI init function too, the vet you wrote vet.
Okay, some. So here, you mean here, right?
Yes, then in the
Yeah.
MPI.
You are right, exactly. So it's supposed, you are right. It's supposed to be after here, right? Yeah, it will be written. Sorry. Because this will keep looping. Okay?
Yes, so say come to the main function again. Down there, where we're calling the function something.
Maybe let me to raise the, I'm sorry. Okay, can you Can you repeat your question? Because still we're new to the system and we try to understand how to raise the. Can you repeat your question?
Yes, so in the MPI, in its function, while you're trying to print the sum of the vectors.
Yeah. So this is just like to show you that like each processor they can run this function and it will print it and will print the value. So all processor will do the same thing. Okay. Later on, we'll do something else because now the idea not just we want to demonstrate that once you run this, it will it will run in parallel, and all of them they will run at the same time and will give you the same result. Later on, we'll talk about the communication. That means how the different processor can communicate because this is the idea behind it. So you are not getting, so you need all this number of processors to work at the same time, but they may have different results, and then you have to do something with this result, right? Whether and there are different scenarios we'll discuss. There is some kind of communication, point-to-point communication, and collective communication as well. But now we want to show you how to run this by using MPI in it. Then you can parallelize. The same code will be run in all processors. Is that answer your question? Is that clear?
But there's also an error in the EX. That's
Yeah.
the step up. What they put the subject.
Yeah, because I think let me maybe we can raise uh, oh, okay, maybe now I can hear you more clearly. Okay, can you repeat your question?
Yes, so I was trying to see that when you record.
But yeah, it's still your voice is very low. Maybe this from the system here. We'll try to find it. But do you think that is any something wrong in the code?
Yes.
Where? Okay. So,
Sound effect. Instead of sound effect, one T, letter T.
okay, into here. Okay, so let's run. Okay. Okay. Oh, yeah. I'm sorry. Yeah. But anyway, you are right because really yeah. Now okay. Yeah. You're right. Will this actually something that we'll try to find out why voice is very low and we are not able to raise it. So this is why we are using this system to test. So MPI C++. Hopefully we don't get any. Okay, that's fine. So now we didn't get any error. So we need to run it. MPI run again Q for to be quiet and MPI. So we're gonna set it to, and because we didn't use any file name, so that will be fine. Okay. So see that this run in all processors and they give us the sum. So the same program. So the same program is it MP C. So it is the same program, but it runs. So that means understand in the future if you have any computing problem, you can create functions and you know how to parallelize it. Of course, in the future we're going to show you how to do some kind of communication between different between different processors, because these processors they act as one team, and each of these teams can do maybe separate kind of communications. Okay, because this is what idea is why we are using parallel system. Okay, and okay, so this so about the communication system. So the idea behind this. So once we there is a communication, we call it communication domain. Once you, so all the processors that you are using them in computing, we call them communication domain. And then you have to create, so just imagine yourself that you are using cluster computer. Okay, that they have different nodes, and each node may have multiple processors, completely independent processors that depend on the network architectures. Okay, there are different kind of network architectures we discussed during the Unit 1. So the first thing that we will create what we call it communicators. And communicators, once you identify the number of processors, those processors will be taken from your computing systems and will be organized in what we call it communicators. So communicators, that mean like a capsule, and that capsule include the processor in which we will do the parallel computing. And there is one important thing here. So those processors will be numbered, will be given a unique integer, non-negative integers, begin from 0 and so on, like 0, 1, 2, 3, and so on. So if you decide that you need 5 processors, for example, so the number will be from 0 to 4. If 10, the number of the rank, this is just like name because they are unique, they will be ranked from 0 to 9 and so on. So we call this, those encapsulated number of processors, we call them communicators because those, only the process that can communicate with one another, and in the future we'll show you how this is going to take place. Okay, so how they communicate together, and also how to create a custom communicator if you not. There are some really important function. So already we know about the MPI init. This initialize the MPI. The second one, the last one, of course, MPI, this will finalize the parallel job. MPI com size, and this it will tell you how, when you use this in your program, it will tell you how many number of processors that you use. Of course, you know that already. You know because you entered that in the command line. But also this function, it will give you, it will tell you like how many processor you have. MPI com rank, when you use this function, it will give you the rank or the ID of that processor. Okay. MPI get processor, this will give you the name or the node name, and finally the MPI finalize, this will finalize everything. But I want you to, you need to declare, once you find, like, because this is address variable, like the word size, so you need to declare this variable. And after that, when you print this variable, you will print, and then of course we'll print these values, okay? So this program, okay, so this, just if you allow me, just to run this program to show you how, because I want you, when you go back to run this program by yourself, okay? B2CBBB. So yes, I'm going to copy it. Okay. So if you see here, we declared this variable like word size, but we provide here an address in this function, and also the same thing for the word rank. Also we provide here as an address, and also the processors. Also we provide it here, and for processor here we need, because it is characters, then also we need the length of that character as well. So we need to declare both these variable, and we need to provide them here, okay? So when you go back and run this, I want you to take notice of this, and after that we print this, we print the processor name, word rank, and the rank. Okay, so this is the rank of the processor, and this how many processors they will be printed. So let's go Sorry, actually, I take some of your time, but just be patient to finish this. MPI, C++, okay, and now MPI run to be quiet. So MPI number of processor, let's go to with 8. See how many they run, and each one here is a rank 6. Of course, they will not be ordered. Why? Because the execution, the operating system cannot control this. Okay, because it's just like in race. Okay, because all of them they run this simultaneously, so you cannot get them in order, in specific order. So this rank 6, but they will begin from 0, 1, 2, 3, up to 6, up to 7. 7, it will be the last rank number out of what? Of 8, because already we provide 8. All right, and also the processor name is Hyperion. So this is our computer name. So this it will tell you how to use that, and when you run that, will so it will be clear. So this is the output for that. This is how to execute it and so on. This we can talk this next time, because this is the last slide, so I don't want to take more of your time. So we'll talk about the different communication, because now we have different processors, and those processors must communicate with one another, and there are different kind also of communications, and the reason behind the communication to do the parallel job. Without it, they cannot do any parallel job. Okay, so this is the idea behind that. So we'll stop here, and next time we'll continue, and so on. Okay, so so do you have any question?